Okay, hello Topcoders, and we are back, and we are live, and
Hello,
we
hello.
are hello, huh? And we are back at the end of this very long day, and those are very long 23 hours. It's gonna be like very long 24 hours. So you can see like very tired faces of everyone present. So there is dimkadimon in the studio, there is JacoCronje and Erin, but everyone is with you. And we're gonna be here reflecting on on this past day. So like I have been following a lot what was going on through the day. Like there was all the things on the positive side, on the challenging side. So like we know that uh, uh it was a very tiring day for the contestants. So like uh, 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 nearly all of them started working immediately. Like we can discuss probably right now, like like how did all the contestants have spent the day. We also want to probably mention that there were some also technical difficulties during the contest, which we had actually like worked really hard to fix. Like so, not everything got properly fixed. That's what we need to give our apologies for that. But we're gonna make sure that the system testing of the past solutions is gonna complete, and dimkadimon is gonna be talking about how we're gonna do it. Make sure that there is no there is no like failures that would be coming from unfair to the contestant reasons. that would impact the final scoring. So that may require a little bit of handling on our side. So there might be some the delays causing from there, but that's probably adds to the long day that was also not only long for the contestants, but for us as well. So let's start like our evening, late night for me. So like early morning for like Dimka, like so it's let's first probably talk about uh, the contestants. Like let's talk like how each of the contestants like has spent the day. Like what do we know about uh, who what when, who slept, who came back, who started late, maybe uh, uh, who tried certain strategies, like in the way how they were submitting the solutions. Maybe like someone submitting everything on it early, like someone tried to improve solutions like later during the day. So let's look at the s- at those provisional score dynamic that we know during the day, at least like while like all those results were stably coming in. So let's talk about that. So Dimka, Jaka, I mean, so what do we know about the contestants' lifestyle? How do they spend this day?
Yes, that's a good question, Renat. Thank you. I think so. We started a forum post. It's called Time Away, and that allows the contestants to mention if they're going to be away for more than 20 minutes. So I can see a lot of people mentioning that they're going to go to sleep or take a short break, whether it's like to have dinner or lunch or something like this, or just to relax. So quite a number of them took some breaks, almost all of them. Um, I think in the beginning, most of them started competing straight away. I know a couple of them were sleeping, or they were there in the initial to read the problem and then they went to sleep. So I know sullyper did that and then he woke up and started competing. Um, so I'm not sure how well that strategy panned out. Maybe maybe it's a good idea to get some rest first and then start fresh.
Well,
What do you
that's how I
think?
usually prepare for my like when I was a student, that's what I was preparing for my like like sessions and like student tests. Like you first read everything right before going to sleep, and then
Hmm.
you kind of like sleep over it. You need to put enough information in your brain actually, like in order for that to work. So if you just read a little bit, that doesn't work that well. But if you actually like load your brain and then sort of like let it process the information while you sleep,
Hmm.
that that may add a lot. That's actually like when you can sleep and actually solve the problem at the same time. So sort of like using this like sleeping period as a little bit of a cheat. But how did it work for him? So like when if you look at his submissions like early on the day, like did he start like catching up with the others like when he woke up?
Uh, so good question. Unfortunately, we don't know any relative scores at the moment because the leaderboard was broken. What we can do is download their submissions and run them locally. So that sort of gives us a good idea because we can run them and compare them to what the testers were getting. And Jaco, maybe you had a look at some of these submissions.
Yes, I did have a quick look at some of them. So I would say halfway during the contest, I did have a look at wleite's solution, and it looked like he already was doing better than our testers. So he's beating my solution and Nika's solution.
Wow,
Not
that's
in all
very
the
impressive.
yeah, so not in all the cases, but
Mm,
most of them. So very quickly we found something that was doing well.
mm. Yeah, it seems that he was the leader, at least in the beginning, as far as I can tell.
Yes.
Yes, I'm looking at like earlier leaderboard days well, it still was working. He was on the top for quite a while, and at least like but he went on top pretty quickly, and then the others were slowly like catching up, which actually uh, gets into basically like the fractions of the point to his score. What sort of like means that the main ideas of at least like everyone would be like everyone were grasping like the most of the main ideas probably of the problem, and then there would be the question of is it optimization of the parameters or maybe like some small type of ideas that like like whether you implement that or not. But at least like what I saw that that by basically the noon, like at least like even like within like 8 to 12 hours, like the scores started sort of like saturate. Like there's a lot of members like having the scores like around like the within just a small fraction of the score from each other. And
Let's maybe talk about possible approaches to this problem. It's coming to an end now, so
yeah, so
just
only
try
10
to.
minutes late
yeah, only
left.
10 minutes left, so there's probably like
So
already time we can start talking
they're
about
frantically testing and maybe doing their last submissions. So
yeah,
we can,
let's talk about first like what happens right now like at the system testing. So like right now they're frantically testing and probably like they're about to submit their last submission.
yeah,
Yeah.
probably just making sure that it works correctly, that it doesn't time out, it doesn't produce any errors, because every time that happens, they get no points for that seed, and that can really decrease their score. I think we're actually expecting the scores to be quite high and close to each other. My expectation they'd be all in around the 90 plus mark. And so any error, any drop in score would be quite detrimental at this point.
Right. So the main right now the main part of this last testing is to make sure that solution is going to avoid failing on any of the tests, and
Mm.
Some
also the main
competitors.
effort.
Oh, I'm
Yes.
sorry, I didn't mean to cut you off there. I was gonna say some competitors may have a couple different versions of their solution that they've been playing with, and now is kind of where they're making that decision of which one are they gonna submit as their final solution.
Mm.
Which one has the parameters tuned exactly the way they like, and they've got to obviously make sure that it works, make sure that it works on all seeds, and then hope that's the best one they've got because this is their last chance to make that submission. So we're not going to see any major new ideas implemented or anything like that at this point in the game. They've already long since implemented whatever they're going to implement.
Okay. Then we should say the wish good luck the contestant with the last submission. Like that's hopefully
Mm.
that they submit the they the because we would actually would love to see it like score the highest on each of the tests and like show the maximum strengths, and we make sure that like from our side uh, the testing will be will be performed properly, so like there are no like errors in the testing on our side. So, and I think it's because it's already like sort of this final polishing of the submission is. So let's probably like go back to the problem. I think there is two things. So like when we were when we were making the writing this problem, like we already probably had certain like strategies in mind, and that's probably like already a time when we can start already discussing them. And let's see like and then we have the solutions and visualizers from the middle of the day, which we can look and sort of like try to guess whether some of those ideas that we could think of were actually implemented by the contestants. So,
Okay.
so
Now,
let's maybe
yes.
like if you can go like through the problem and sort of like when you're building it, like so try to like pinpoint sort of like what were kind of like the main elements that you need to keep in mind to actually like solve this
Yes.
problem.
Yeah. So a standard approach would be, so firstly you need to pick a tile, decide which tile to use, and then decide where to place it. So a standard approach would be to have some kind of a function, heuristic function that gives you a value for how well that tile fits into the specific position. So in this case, that heuristic function might be looking at the actual values of the score. Does it match the neighboring cells? So as you know, high-valued tiles score much higher. So when you place a tile, you look at the neighbors, and if it match, you give it a positive score. If it doesn't match, you give it some kind of a negative score in your heuristic function. You penalize, bad placements. Other thing to keep in mind with this is to, I think, keep some of the tiles close together. So if you leave gaps in between, it might be difficult to fill that with coming tiles. The other thing is the border. So we know there's a perfect solution for every test case, and that solution, we know the zeros is all around. So
Around the
then,
border.
yes, and the corner tiles actually, the four corners, you know exactly because they've got two zeros in them.
Yep. So there's no options for them.
Yes.
But if you see a zero, like does the in the ideal solution is it always like at the corner, like, or is it always in the side, or like it could be in the middle as well?
No, zero
It's
is always on the
always
edge.
on the border in there.
Yeah.
Right, and you can actually like grasp it from just the overall number of the zeros. So you probably know that the number of the zeros is equal to the perimeter of the square.
That's correct. So should they try to go for the optimal solution, or should they just try to sort of maximize what they can?
But that's a
See,
question of probably of the size of the board they're trying to solve. So like if it
yes.
is a small side of the board and there is a lot of tiles that they have sort of like on hand, or there is like a high, for example, percent of the tiles you can recycle, then you can sort of like expect that, hey, there is actually a chance to get a perfect solution there, like, and that's a pretty feasible chance. And actually evaluating that chance is sort of like part of the challenge here. So like how probable it is that you can actually guess the full the perfect solution. But if you do, then you already would try to place those tiles like based on all those zeros. You know that they need to go somewhere, so you would never place some other tile that is a non-zero, for example, close to the side. But if you try to overly aim for the perfect solution on bigger boards, then you may just start limiting yourself in matching, for example, large numbers.
Yes. So, Rinat, so the other important thing of this problem is the discards. So there's different strategies to that. you can discard everything up in the start, which gives you a lot of information throughout, the whole test run. But it's maybe better to discard as you go and not, up front. So it will be interesting to hear what the contestants did when they discarded and what do they do. It's very helpful to have some discarded tiles, because you can take the tiles in your hand and the discarded tiles and then run some optimization algorithm like simulated annealing, beam search, things like that, to try and find the best place to place these tiles that you know is coming, or that you have. There's also the other Nika, the tester. I guess I can mention this. He also used a clever way of where you can predict what tiles is coming. So there's no rotation in this problem. So if you have a 20 on the left of a tile, you know there's going to be a tile with a 20 on the right.
Yeah.
And that information you can use. Yes.
To predict what future tiles are. And I think the closer you get to the end, the more accurate your prediction will be, right? Because
Yes.
you've collected sort of more statistics. You're keeping track of all the counts of how many times each number appears on each edge.
Yes.
I'm
And
guessing.
also for different use case, for different test cases, like there could be different strategy here too. For example, if you allow very large span of the numbers, but on pretty small board, then you may actually have like, hey, if there is like a tile with 20 on the side, then there may be only one other tile with a 20, for example, on the left. And so like if you just see those two numbers, that will be just components of a perfect solution. So the larger span of the numbers, like for the smaller board, the higher is your actually chance to figure out the perfect the perfect solution. At least that will be my guess.
What kind of size can you solve perfectly? So when I was playing it in manual mode, I could solve n equals 5 and sometimes n equals 6, especially if there's enough discards. I would place the zeros because I can kind of know where they have to go, especially the corners, and then discard the other ones.
Yes, and then in that case, when let's say you look at the left border, you know the corners, but if you get a tile with a 0 on the left, you actually can know that position as well, because if it doesn't fit at the top and doesn't fit at the bottom, it must fit in the middle.
Yeah.
So the border is pretty easy, I would say, to get correct.
Yeah, so maybe kind of start around, fill in the border, and then work your way inwards, because the next layer of tiles, once you've already placed the border, then you have more information about the next layer and what they need to be. Of
Yes.
course, sometimes there could still be multiple options, and you sort of need to guess the best one.
I think the higher the C value, so the more the maximum number, the more different numbers you get, the easier it gets to solve the smaller cases.
Okay.
Because you don't get, duplicates.
There's less guessing.
Yeah, there's much less guessing then.
Yeah. But at the same time, when C is very small, like I think the smallest was 2, you'd get a lot of duplicate tiles. So
Yes.
maybe guessing is not so bad in that case.
I see.
Well,
There's
similar
probably
thing.
a sweet spot in the middle somewhere.
This is where that all-important heuristic function kind of comes into it, where you want to You want to try to estimate with some sort of a mathematical basis which tile is most likely to be the most helpful in which place, and which places are going to be the most helpful to your score. And being able to come up with a good way to represent that in some sort of a function is hugely helpful. How exactly one does that, I'm not sure the best approach, but that's, I think, what a lot of contestants probably spent their time working on the most.
Yes, and it's important to, I think, penalize the empty cells as well. Not entirely empty, but with a tile on the edge of an empty tile.
Yeah, so when you're thinking about that heuristic function, there is like several probably parameters of the tile that goes here like in the calculation. Yeah, yes, technically yes, we know that if it is 0, yes, it should be on the edge. But if it is a small, like for example, the board, and we're trying to aim actually for perfect solution. But for example, the bigger board. So the other numbers on that tile may become actually like more important there. So and like how do they fit? Like whether they fit already very well with already existing tiles on the board, whether they can score high, and also what empty spots do they leave? What kind of empty spots do they leave on the board? Because the more surrounded empty spot you leave, the lower is sort of like the chance that you get exactly the tile that would match that that spot. So like, and most probably you'll have to fill it in by random by something, and
That's where
so
the parameter tuning comes in. So what they normally do is you test over thousands of test cases, but you tune the parameters for certain sets. So if n is low, you have certain parameters that you use, and if n is high, you use different parameters. Same for C, and all the parameters that change with the test case. To try and find the optimal parameters to use in certain test cases.
yeah, that's what I saw that like at least in some of the solutions, I think on like on visualizer from the wleite, like for example, that on a bigger board, that he will be matching like reasonably high numbers, like getting a lot of score, but at the same time, those matched tiles like we're creating basically nearly like a fractal type of structures on the board. So you would get both like the elements of the greediness, but at the same time the uh, like fruitful opportunities to place others to place the potential tiles in the structure where you can pick and choose like where a lot of like when you create these fractal structures, you get a lot of surface around them where you can have sort of like high probability where you can put for that the new tile may have like a better match. So that's so then in some parameter cases like that those structures might actually like rise, and probably like if you look at the visualizer, so you just have like that in various use the parameter cases will have like quite interesting visual structures of those, especially like in initial steps. That's what you want to see, like when the probably most interesting part of the solution happens at the early on, where you can see like, hey, like what structures it's creates on the board, and also how many how many tiles are getting discarded at the beginning.
So I want to mention that we've got some people, some competitors waiting to be interviewed. So let's let them in.
That's right. That's a man.
And ask them lots of interesting questions.
Hooray.
So, welcome everyone. Please introduce yourself. I can't see who's who.
I don't know who is here. Can you hear me or not?
Oh, we have
Yes, we can
sullyper
hear you.
here. Yeah, hello
Yeah.
Benjamin. Great to
Hello.
see you here.
Good to see
Welcome
you.
after a long day.
I don't see my camera, so I don't know if is my camera
Can-
on or not?
Yes, we can see you.
Yes.
I can see
Okay.
frictionless is here. So,
Hello. Yes. Awesome. Jeremy.
Yes.
welcome, Jeremy.
Welcome, Jeremy.
And we've got Laszlo.
I think we have a last line and we
as well.
have earlier gedacht.
Feel free to introduce yourself.
Mm.
And we have Ralph, but we can't see.
Yeah,
Can't
sorry,
see.
Zoom somehow refuses to detect the camera right now. I can try to leave and join again.
Yes, if you want. Yeah, meanwhile, how did you guys go?
How can we know? I don't know.
Well, that's
I've never been.
I mean,
that's the question
that's
of
a
the day.
great issue.
I
I
guess.
know some people. I know some people say they rather not come to the interview if they didn't do well, and now they're showing up because they don't know if they didn't do well or
Well,
not.
you don't
And,
know how well you went, so.
And I'm one of those persons. Well, I'm expecting to not have done great, but who knows? We'll see.
Well,
Yeah.
I guess there is some positive part of it. So like now we have this, the Schrödinger uncertainty, like a little bit at the end, where
This is a new type of contest that we
new type
invented,
of contest.
where you don't have a public leaderboard, so it's full of surprises.
No,
So
you have
all-
one. You just cannot trust it. And
Yeah, it's adversarial
Yes, it's
scores.
called a cat in a bag.
Yeah,
was
so how do you deal with that? Like, how would you do your testing without that
Well,
information?
I mean, anyway, most of the time I don't really look at the leaderboard that much because some people. I mean, when you do long contests, some people might show up later. Some might be waiting before they submit. I actually sometimes do that when I know I won't have much time in the final days. I might keep my best solution and only submit at the end. So you can't really trust anyway what you see that much. So it didn't change much. I mean, I'm just running local tests on as many seeds as I can and pick whatever looks the best locally.
Okay, so it didn't affect you too much.
It's good to have some idea if you're completely off or not. Because of course, if you see someone that has a much higher score than you, it gives you some information that maybe the strategy you're using is not the best one. Maybe there's something else that you're missing. But other than that, you can't really trust too much. Like if it's close, you don't know. If you're 1 point behind, you are 1 point ahead, or it doesn't mean much.
Yep. And what about the other guys? How do you feel?
Yeah, at least the local tester was working great, and so that's
Okay.
that's
Well, at
what you
least
rely
that was
on.
working.
Yeah, and we also got access to this AWS instance, so testing was, at least for me and my slow computer, a lot faster than usual. So it was, despite the broken leaderboards, even a better experience than usually for me at these marathon contests when it comes to local testing.
Okay. Yep, that's good to know. All right, let's talk about the problem. I think that's what everyone wants to hear.
Yes.
How did you approach it?
What's the
What
impression?
worked? What didn't work? I'll start with you, sullyper.
Yeah, well, so I started the competition by reading the program and then going to bed.
That's what we have been discussing.
I don't know if that was a great idea or not, because obviously I didn't have a good night of sleep for many reasons. some involving thinking about the problems, some involving my kids. So basically, yeah, like the idea I got when I was trying to sleep was just to first basically discard. I mean, try to find the best strategy to know which one to discard first, but do all my discard at the beginning, and that gives me some information about coming tiles, because it doesn't matter if I can already place them virtually even if I don't have access to it, because I know I would get them later.
Exactly.
And after that, I was just using some simulated annealing to place the tiles, and every time I get new tiles, I was doing that over and over, and I battle all my morning with stupid and random bugs that I still don't understand. When I put assert, suddenly things start to work. Anyway, so I wasted a lot of time this morning just with bugs, and after that, I didn't have much energy to try anything else, so I just tried to customize a little bit the heuristic and these kind of things, like in my simulated annealing, but nothing too fancy.
What kind of scoring function did you have?
It's pretty much so for a grid of size 4 or 5, I penalize heavily to not put the edge correctly, because it's actually, especially for n equal 4, it's pretty easy to solve. Not all of them, but I think at the end I can solve 2/3 or 3 or 75% of those, something like that. But other than that, otherwise is basically it's the row score when it matches, and if you have a mismatch, I don't even know what I add at the end, but I had some custom function where I was penalizing if you didn't have if you had a mismatch, and that was pretty much shit. The rest of the heuristic were more about which tile to place first and which tile to discard first. And Sam, my brain is a little bit fuzzy. I don't even know what stick at the end, because it was a lot of time he went against my intuition. I put a function in one direction and the score get worse, so I tried to put a minus, and then suddenly it improved. While in my mind, it should have been the opposite. I think, for example, I was suspecting that keeping the big tiles with a heavy number is better, because when you have more information, you can probably place them at like better location. But it turns out that I was scoring better when I was like placing them right away, and keeping or like discarding or like placing the low tile later. I don't know. It didn't seem intuitive to me, but I probably have a bug somewhere. But it was working better, so that's what I did.
I think
Excellent.
I had the exact same experience flipping the sign for that exact same reason in my solution.
I don't know.
Do you want to frictionless? Can you tell us more about your solution and your approach?
Yeah, it sounds very similar to sullyper's. Really, I pretty much only had two solutions. I submitted a greedy and then I submitted a simulated annealing, and I think I could describe the greedy first because of the heuristics kind of fed into the simulated annealing. So with the greedy, it was just, you have this many tiles and this many empty spaces. Try to figure out which tile and which empty space gives you the best heuristic score. And it really is just about like you're putting a tile in and it has up to 4 neighbors where you may be causing two numbers to come together. If those two numbers match, then you use the scoring function from the problem. You use the cube of the number and add that to your score. But to penalize putting two numbers that don't match together, I actually would want to subtract the score there. And in that case, you actually have two different numbers. So you actually want to use the cube of both of those numbers and subtract them. So then
Right. Okay.
similarly, like if you're putting two numbers that do match, then you need to add twice, like the cube of both of the numbers together. So that was just like my really simple first thing I implemented, and then my real solution, yeah, sounds like pretty much the same thing. First discard, use all the discards to collect as much information as possible about what tiles exist, and then on each turn, all the tiles that you know about, meaning all the discards plus your current hand. Use simulated annealing to try to find the best placement you can for all of them using basically the same scoring function, but for all the tiles rather than just one. And then, and then choose one of those tiles to actually place. And on the next turn, then you start over because you have a new information about a new tile. And so as far as which of the tiles to place, I just placed the one that had the best greedy score itself, so that because you still, even though you've done the simulated annealing, you still don't have complete information. You still are missing information. So the greedy helped a little bit there. And that's with that. Before didn't further.
Oh, thanks for that.
Yeah,
How
so
about you, Ram?
the
Can you
early
tell us more about
discards
your
was the
approach?
obvious idea that we probably all had. I found one counterexample where I discarded a corner piece because there was only one piece available. And
That's
of course, the
interesting.
corner is obviously where to place. And at the same time, I was missing the discard later, but this was such a rare edge case, so it was not worth dealing in this short amount of time. And the overall problem felt more like a beam search problem to me, so that's what I did.
Okay, interesting.
Yeah, and for the beam, I tried to eliminate my possible number of actions because there are a lot when you place multiple tiles. So initially, I placed each tile individually without placing any others, just to see how the score would change. And then sort the possible actions by score to then, in the later main search with all the tiles, only take the top few options and those neighboring those I newly placed. Yeah, that's pretty much it. And the scoring function itself, it's really short. It's just like 5 lines or so.
Okay.
About not placing edge pieces in the middle or middle pieces on the edge. And obviously getting same numbers together.
Okay. Very cool. And last one, Lashley. How did you approach it?
I started with a heuristic greedy, pretty similar how frictionless did, but first it was very simple. Just I focused on the penalty. So how much do we lose if we put down the tile, and which is the place where we can put them with the lowest penalty. And actually, I have used that all along, improved all along, and only in the finish I used simulated annealing for the known tiles. And as an exception, I do not reveal at the start with discards. I try to be smart about when to discard. It doesn't matter too much, but I added a few options where when I want new tiles along the way. But otherwise, I rely on the actual greedy method to put the tiles and wait till the end where I get the complete information.
Okay, very cool. Thanks for sharing. I have a question to you guys. Do you perform any prediction of what future tiles will come? And how do you do that?
I only do that for the last one.
Oh, just the last one.
Yes.
I didn't know what to do, so I just did it for the last one. So the last one, unless you basically have the same number top and bottom or right and left, you can know exactly what it's going to be.
I had that code, but cannot submit without. So it was too risky for me. Yes.
I did it. I ran some tests. I didn't see any improvement, but it was there. It did.
It's
I
only
just
one
guessed it.
tile, so can't
Oh.
give you too much.
Well, for small grid, one tile can give you some information. Like for big one, anyway, it's one tile. But for small one, like
Yes.
well placing one tile can have a big impact. Like because
Yeah.
you don't have that many tiles to score.
Yes. If you
But
have only
yeah, you didn't
a
have much
single
impact
tile,
anyway.
if you have only a single tile plus a few in the crowd, then it's important. Yeah. But yeah.
Apparently, my local scoring say it wasn't important, but yes.
Because you
That's the
run
only prediction I
simulated
did.
annealing for the whole thing. For me, it must be important because I don't run simulated annealing just in the end, and that one additional tile could have helped.
Yeah, you just get it pretty late. I mean, the thing is, for big grids, it doesn't really matter because even if you predict it, you most likely have single hole where your other tiles are gonna go in, and you don't have much choice.
It's true.
So it's
Yes.
really only like for small grid that maybe you might have more chance to be able to use it, but it didn't seem to have any big impact. So yeah, I didn't do any prediction beside that.
But you could do counting, like how many, for each number, you count how often it appears on each edge, and then you know that there's an opposite number coming on the other side of the
Yeah,
edge.
but
Can you do some statistical prediction of what's coming? Was it too hard?
So I think it's only gonna really work right at the end. Same reason like why the last tile is working. And if you don't have the full tile, because if you do that, you're only gonna have like you might not even have right and left. You know that if you're missing like 2 or 3 tiles, like it might be 3 different value for the left and 3 different value for the right, and you don't know which one is gonna go
Don't
with
know
which
how
one,
they.
and it's not gonna help you that much.
But just incremental improvement, like probably like how to notice.
I mean, maybe with more time there's something to do here, but that was I thought quickly about it and decided that was probably not gonna work and not worth the time. But I mean, maybe someone else did it.
I kind of have a follow-up question to that. Were there any ideas you came up with that either you found out didn't work really well, or any ideas you came up with that you didn't have time to implement? That goes to all the contestants.
Like, so I'm gonna, like I'm talking, so I'm gonna answer right now and answer after. But I mean, obviously, simulated annealing was not the only way to play style. I thought about doing beam search, but I didn't think it would necessarily give better results or worse results. I thought it was just gonna be similar at the end, so it was not really worth doing. In a long competition, I'll probably try it because sometimes you get surprised. But here, I thought it would just be wasting time. And then surprise, I already mentioned earlier. Sometimes I come with some heuristic and then the score gets worse and I reverse the heuristic and it works. So that's a surprise. That's something that was not expected.
Thanks.
Anyone else?
And anything which I tried today stopped working. I mean, my heuristic was probably on the edge, so yeah, basically stopped improving. Either negative or positive signs. That was the I don't know, 2 o'clock in the night when it was the last improvement.
Did you change your approach based on the value of C? Because I know for large C, it might be easier to solve.
I didn't.
Okay.
I just did some brief experiments. I was trying in my heuristic scoring function where there's the positive component for numbers that match and the negative component for numbers that don't match. I was trying making those not equal, making one of those pieces larger than the other, and at some point when I was getting a very slight improvement. So I thought to see, well, is this improvement coming more from lower or higher C, lower or higher N? And it seemed actually most of the improvement that was coming from that tweak was in the low Cs, but not the high Cs. And I don't actually understand why. Every one of those experiments was a long time running tests just to get a very small change. But I saw at least one small effect from that.
I also tried that. It didn't work really for me. I was surprised that even very low Cs work the same way as the others. And yeah, I forgot to mention that in my penalty, the penalty only kicks in for the higher values. I mean, for the lower values, I don't care if they are lost or give way less penalty. Only the high values matter because of the scoring function.
And I think here you also have like two different things that go against each other. When you have low C, maybe it's harder to solve fully, but you're gonna get more tiles with the values that you're looking for because you don't have a wide range. When you have a high C, for like small grid, maybe it's easier to solve, but when you get to a big grid, then suddenly you know, if you have two neighbors tiled place, you have like not even 1% chance to get it. Like you have a very tiny probability to get a tile that's gonna match if you haven't seen it yet. So I don't know if high C would necessarily be easier. Actually, I don't remember. I would have to double check. But the good thing about this problem is you can compute easily the optimal solution. Given that there was an optimal solution, it's easy to find the score, not to find the solution itself, but to find the score. And I don't think that I was getting a very different score based on C overall. I think at the end I finished at about 84 point something % of the optimal.
Okay.
And I would have to check because I was looking more about N than C generally when I was looking at subset, but I didn't really see any patterns or like things that was like very off.
That's how we can get our leaderboard. I think I was about 82% of the optimal on mine.
Yes.
Okay.
You also reminded me of one idea I did have that I didn't implement, which was to try to penalize situations where you have an empty square with two or more large numbers next to it, because that would be harder.
It won't work. It won't work. You saved yourself some time. I spent almost a half an hour today. Yeah. Because there are too many which we need to fit, but it won't work.
Yeah, I tried something similar where I was looking at the number of neighbors and I don't remember if it was penalizing or giving a bonus when it was still empty, open, but basically it was I was sorting the value like by increasing order and putting a different coefficient in front of it. So basically I was assuming that the bigger value might get a match and the second one is unlikely to get any match, and the third one, fourth one, if you have those, like you're never gonna get a match. But yeah, same thing, it didn't really work. I think the main issue was just it was slowing down too much my code, and I was not getting enough iteration in the essay anymore.
Speaking of optimization, what kind of things did you try there, like bit boards or anything like that?
Nothing.
Nothing. Okay.
Not really. I did get rid of the use of the exponential in my simulated annealing, but it wasn't really a big deal either way.
For beam search, you're likely to copy a lot of state, so that's the only thing I optimized a little bit by pre-computing the score and then only creating the new board objects and copying all the tiles and such if the score is high enough. And this is also the last improvement I got by improving the performance, so I could use a higher search depth.
And you had a nice priority queue?
No.
Okay.
I know why you're asking.
I guess I should say that at least for the simulated annealing, the score update was incremental rather than having to process
It's
the whole
important.
board, of course.
I struggled with that because of the neighboring items that need to be handled a little trickier.
All right. Jaco, did you have any questions for our finalists?
Yes, maybe one. Have anyone thought about using Hungarian algorithm, to change it into a matching problem? So the tiles that's not neighbors, you can find the optimal position for them by changing it to an assignment problem instead of using simulated annealing for that.
That's a good question.
I did not think about it, and it's too late here for me to think about it right now.
Okay. Yeah, it would be interesting to see how that compares to the simulated annealing. It does found the optimal solution for those disconnected tiles, but you can't
I
use
guess
it always if there's neighboring ones.
if you had all the tiles, Hungarian matching would be quite good because you can get every second tile you can place perfectly. So you can get half of
Yes.
them.
And can you use Hungarian with the dynamics, how tiles relate each other? I'm not sure.
Yeah, so
I'm Hungarian, so
they're not next to each other. So I think at the end, I would guess the boards will add pretty, lots of empty holes in them that you need to fill with the last tiles. So that would work pretty well with the Hungarian
yes,
one because they
for
don't have
those,
neighbors.
sure. But there are groups, or at least in my greedy method, there are some parts which have neighboring tiles. Well,
Yes. Mhm. And then you can sort of decide, okay, I keep these ones fixed, so that there's no neighbors, and you try to solve the others. And then the next turn you put the others that's been fixed into the algorithm to try and optimize them, something like that.
it could be.
Yeah, you can sort of alternate between odd and even tiles,
Yes.
fixing one, the other.
That
What
was
about dealing?
sorry. That was also a first idea, the chess table thing, and I was surprised that my greedy algorithm did it itself. There was no need for coding it.
I have one more question. Dealing with zeros, do you always try to put them on the border? And do you put the border first if you can, or you can put them anywhere?
I only kind of not really force it, but put a high enough penalty that it's pretty much forced for size 4 and 5. Above that, he was actually not helpful. And I think thing is 0, they have to be on the border if you have an optimal solution, but if you're not going to be able to reconstruct it anyway, it's not going to help. And the 0 can be helpful to, it's a low score that you will be losing. I mean, the way I was using it in my scoring function, if you cannot get a match anyway, it doesn't matter if you put a 0 or anything else. And you don't get penalized too much for 0. So 0 ended up to be in the middle as well. But yeah, so only for a very small grid, I was kind of forcing it because then you had a chance to reconstruct it.
So in my scoring function that I described, the 0 would have no contribution at all. You cube it and it's still 0. And so I found some replays that I watched looked a little awkward. And so what I actually made one tweak to my scoring function so that instead of using the cube of the number, I would use one higher number and cube that so that the 0 would actually become a 1 instead, just to give some very minuscule scoring hint, so that if it didn't matter where to put this tile, well, okay, put it on an edge. I didn't see that happening much in general, because usually like you had information about enough tiles that you've had some reason to want to put this tile somewhere else to make some other larger number match with it. But and I'm not even 100% sure if I got a bonus on like score for that. If so, it was pretty small.
Yeah, there's cubic scoring function that really favors like big numbers. So it's like everything that is small kind of like becomes all the same unless you're really like trying to reconstruct the perfect solution, which is possible only for like very small boards.
I have only realized that reconstruction thing the last day, and I tried to shoot for the edge zeros and corner zeros, but then I realized that it made my solution worse. So yeah, it's just generic building of the a good solution, what we can do.
What about you, Ralph?
Yeah, I agree. So I gave a little incentive of putting corner pieces to the corner and edge pieces to the edge. But if I did this too much, then the score actually decreased. So I had to stop at some points. And the important thing was getting the big numbers together, and those zeros didn't matter too much.
And okay, not related to the problem. How did you guys deal with the 24-hour contest? Because that's very different to a 7-day contest. And how did you decide when to take breaks or eat and things like that?
Okay, so for me it started at 9 in the morning, which meant I started right away until lunch, when I ate something and came back. Then at some point I just got mentally exhausted, didn't have any more ideas, so I took another break, just went for a walk in the park. Then I later came back, made some enemies, I think, because I didn't check Zoom, and in the chats they told me my screen went black, so I wasn't sharing anymore. But I pushed the Zoom window so far outside because it was just disturbing me and blocking the view, so I didn't see the message in the chat that I should share again. Yeah, and then at some point it got late and I was even more exhausted, so I just went to bed and came back this morning.
So for me, the contest started at midnight, and I decided to take a little time, not just to read the task, but to implement just the basic infrastructure enough to parse the inputs and have like a trivial solver that just places the pieces in order, for, a couple hours before sleeping, so that I could, you know, do the more serious work when I woke up. And so, of course, had some trouble sleeping. I was thinking about the problem, and so once I kind of came up with the first greedy thing that I was going to implement, then that was good enough, and I could get some sleep.
Yeah, I already described how it went for me, right? But basically, I read the problem, went to bed, woke up when my daughter woke me up, and after that, I took a few breaks during the day, but mostly I stare at my screen and it's like not understanding why it doesn't work, and yeah, that was it.
For me, that first 12 hours was really great. I don't used to play that focused unusual marathons, but I managed to do it. But after that, I became tired, so yeah, not much happened after. Little bit rest with a bit of food, drink, and lots of failed attempts to improve the solution.
So how do you all think you went? Like, who will win? Any predictions?
Just can't say in this contest.
What I saw on the leaderboard when it worked, that Diver was strong.
Okay.
But okay, yeah, but when was that? Because I never saw a leaderboard
I don't know.
working.
Yeah, it's true. a few times in the nights, but yeah, after that it didn't work for the last 6 hours. So
Yeah,
I don't know.
There was a time when a decent fraction of the people had scores in that 20 range, and it seemed like you could kind of compare those, but
But
and
I'm
based
not
on that,
sure
I
about
was
that.
I don't know.
Because I thought about that, but then at some point I had like 17 and some people had 21. And
yeah, I
I
was on
was
the
not
low
that
end
far from the
too.
optimal. I wasn't that far from the optimal, so it looks very fishy to me. I mean, it's not impossible, it's on 100 seeds, but I was like further away from them that I would be from the optimal, apparently. So that's, I don't know. It looks really fishy to me, but it's possible.
Yeah, the thing I was going to say is that I kind of thought I was doing pretty badly based on that, but then it looked as though possibly I was being scored based on my earlier greedy solution rather than the actual simulated annealing solution. So, and it sounds like some other people had that too. They were maybe their older submissions were running. So, yeah, can't really trust it.
All right, I think we're getting close to our scheduled time for the interview section of this broadcast. So does anybody have any final thoughts they want to add in, or anything else they want to say before we call it a night?
Thank you for broadcasting. I think I'll watch back what I missed during the contest because I'm always curious about how other people work and how they write code, with what IDE, what's their local setup. So I will take the opportunity then.
Thank you. I wish you all good luck. And despite the problems, I hope you had fun and enjoyed yourself.
It was a good problem, definitely.
Yeah, thanks for the
And the film was
contest.
good
Thank
for
you.
the final.
So yes, all the best.
All the best.
Yeah, have a good rest.
Great, thanks everyone, and
Bye,
Bye,
good luck to
everyone.
everybody in the final standings.
Thank you. Sleep well.
Sleep well.
Goodbye.